Hello world, this is Joe Strout with Mini Micro. I got a request on the Discord to make a simple game and show how it's done. So that's what we're going to do today. So today we're going to make a game where you play a little cell swimming around in a pond of cells, and if you touch a smaller cell you engulf it and get bigger. If you touch a bigger cell though, it's game over. So that's the objective. Where do we begin? Well, when you launch Mini Micro, it's going to look something like this, or if you've already been using Mini Micro a while, then it might be a good idea to use the reset command that clears out any previous code or global variables. And then I like to save right away so that I don't forget to do it later. So I can type save even though our program is empty, and we'll do save cell. I don't have to say cell.ms, it'll fill in the .ms extension automatically. So now we're going to edit and get started. So let's see, the first thing I usually like to do is clear the displays. We have an 8-layer display in Mini Micro, and by default, whenever you clear, the display 4 is a Sprite display, but it doesn't have a convenient name. So I like to give it one. We'll say disp equals display 4, and now whenever we want to refer to display 4, we can just use disp, which is a little bit shorter. Rather than loading an image file for our cell image, since I don't have one handy, I'm just going to create one on the fly by drawing into a graphics display and then plucking the image right out of that graphics display to use for our sprite. So let's do that. We're going to draw our cell at a size of 128 by 128. Because computers just like powers of 2. You don't have to use powers of 2, but I like them too. So GFX, which is the default graphics display, fill ellipse, and let's see. I want it to have a border that's 10 pixels thick, so I'm going to inset this fill by 5 pixels and inset the width and height, or reduce the width and height by 10, so instead of 128 it'll be 118, and we'll make the inside gray. And then we'll draw the border with draw ellipse. Same coordinates, and we'll make the border white and give it a pen thickness of 10. And let's just run that much and see how it works. So the habit I've got my fingers into is to always hit Control S, which is save, and Control W, which is exit. You could also use the buttons at the top of the toolbar. Now we run, and there we go. It cleared the screen and it drew our ellipse into the bottom left corner of the graphics display. So back to edit. Let's grab that as an image and make a sprite subclass that uses it. I don't need a comment for that. You know what I'm doing. So we're just going to say cell equals new sprite. I've used a capital letter here because my convention is to always capitalize things that I'm going to use as a class, but lowercase things that I'm going to use as any other variable or an instance of a class. Cell here is a class. We're going to have lots of cells, so I'm using a capital C. And now we can give it an image, and that'll be inherited by all the cells, getting the image from our graphics context, gfx.getImage, and coordinates 0, 0, 128, 128. And let's try that out. Now we're not going to see anything just from creating a sprite because we haven't added it to the display, but let's exit, run that, and now we have a cell, and we could add it to a display to try it out. So let's do disp.sprites.pushCell, and there it is. Oh, I see I've forgotten something because this area here is not transparent like I intended it to be. So let's fix that. Before I start drawing into my graphics context, I want to clear that to clear. By default, the global clear command sets up that graphics context to solid black rather than clear, or transparent. So we want it to be transparent. Let's run again. And by the way, the command prompt here supports a history of previous commands that you get to by pressing the up arrow key. So that's how I'm doing this. And hey, now it's nice and transparent. We can move this around. We could say cell.x equals 300, cell.y equals 200. Give it a tint. That's a color that we want to apply, color.yellow. Or we can specify our colors in HTML format, basically. Pound sign followed by something like red, green, and blue hexadecimal. Oh, that's the same as yellow. That was a terrible example. Let's do this. This should be pink. Yeah, maybe it needs to be a little bit pinker. There we go. All right. So anyways, the point is we have a sprite, it's called cell, and now we could create a bunch of subclasses of those and add them to the display. So first though, let's create a cell that represents the player. I'll put in a comment here. So we're going to say player equals new cell. I'm using a lowercase p here because this is a particular variable, not a class, that I intend to use with new. We'll give the player a position right in the middle of the screen. The screen is 960 pixels wide by 640 tall, so half of that is 480 by 320. And we're going to start it off kind of small using the scale factor here of 0.35. And I'm going to give this a bluish tint and push it onto the display. So disp.sprites, push player. Let's save and exit, try that much. All right, here's our player cell. So far so good. Now let's create a bunch of other cells in random positions and sizes. We'll say other cells. By the way, I hit Option delete or Alt delete to delete entire words at a time. That's basic editor behavior. Okay, so let's make a for loop here. For I in range 30, that actually goes from 30 down to 0, so it'll actually be 31 cells, but that's okay. I just pulled that number out of the air anyway. We'll say noob equals new cell and give it a position randomly on the screen, 960 times RND, which is a random number between 0 and 1, and 640 times RND for the Y. We'll give it a random scale too, which will be based on the player scale. So random is a number between 0 and 1. If we subtract 0.4, then it's a number between negative 0.4 and 0.6. Relative to the player scale, which might actually be a little too much variance. I'm going to multiply that by 0.5. We'll just see how that works when we try it. And then we'll give it a tint. These are the enemy cells, if you like. We'll tint those pink. I like the pink I came up with before. And push them on the display. All right, and then let me show you the trick I just used there. When you've got something like a for loop open, you can push shift return and it will automatically close the for loop. Puts in a blank line as well though, so I took that out. All right, let's save and exit, run that. Hey, we got a bunch of cells. Something else we've forgotten though is our graphics display still has our original cell prototype hanging out there. Let's fix that. As soon as we've grabbed the image from the display, we don't need that on there anymore, so we can do graphics.clear. There we go. All right, so let's see. We've created the player, we've created a bunch of other cells. What's next? How about we make the player cell move around? So we're going to give the player an update function, and we'll just call that on every frame to get some animation. So create a function, shift return. We're ready to type inside it. I'm going to make the player cell follow the mouse, move towards the mouse wherever that is. So first we need to find the difference between the mouse position and the player position. So dx will be our difference in x. It's equal to mouse.x minus self.x. So this is a method on an object, and so I have access to a special variable called self, which refers to the object that the method is called on. That's what's going on there. So our dx and our dy, we're going to find out what that distance is so that we can normalize those differences to a total length of 1. Take the dx, square root of dx times dx plus dy times dy. Could have also used the power operator, but I don't know, for old habits I just like to multiply a variable by itself. And now we're going to say self.x equals self.x plus dx divided by the distance, and same for y, dy divided by distance. And try it out. Nope, nope. It doesn't do any good to have an update method if you never call the update method. So that's kind of important. Let's go down here and make a main loop at the very bottom of our program. We'll say while true, which makes an infinite loop. I hit shift return there and it completed the while loop for me. Player.update, which calls our update function that we just defined, and then yield, which just makes the machine wait until the next frame at 60 frames per second. So that should give us something. Hey, there we go. It's now following the mouse around. Not super fast, but it's doing it. Now there's also no inertia. It instantly goes from one side to the other. It never gets any faster or slower. I feel like controlling a cell in a big pond should be a little bit more slippery. So I want to add a little bit of inertia to that player cell. So let's see, to do that we're going to define a couple more variables here on the player. Vx for velocity x and Vy for velocity y. And now let's copy these lines and change it so that it's the velocity that increases towards the mouse position. And then the velocity gets added to the cell's current position. So this basically implements our inertia. And actually, if we don't bound this somehow, this Vx and Vy is going to grow really large really fast. So I'm going to add a bit of simple friction by just multiplying our new velocity by a factor of 0.9. And at some point this 0.9 factor will balance out the velocity that we're continually adding, and we'll have a top speed. And we'll just see how that works. Oh, what did I do? Vx is unknown. Okay, right. Vx and Vy are not local variables, and anytime you don't have some other kind of qualifier, you're referring to a local variable. What I meant here was self.vx and self.vy, the properties defined on the player itself. So, oh, by the way, when things went south there and I broke out of it, how did I do that? I did that by hitting Control-C. And after you've used Mini Micro for a little while, that becomes so habitual, you just do it automatically when things go haywire. So that's what that was. Well, let's try again. Hey, there we go. Now it's chasing the mouse, and it gets a little bit of speed, but it doesn't get too out of control. I think that's pretty good. All right, Control-C to exit. Okay, now the cells are just sitting there. They're not moving and they're not reacting to touching the player. So let's see what we can do about that. I'm going to add some methods to our cell class right up here, and some properties. I'm going to give cells a velocity just like the player. In fact, since player derives from cell, I don't actually need these anymore. And then I'm going to give cell an update method as well. It'll be different from the player's update method, but that's okay. The player class, can just override the cell's method. So here's what a generic cell will do. It's going to start with, actually, this part is going to be the same. Applying, well, not exactly the same, but it'll still be useful to copy it. Instead of having the cell go towards some specific direction of the mouse, though, we're going to have it just add some random wiggle. So we'll do random minus 0.5. Again, random is a number from 0 to 1, so if we subtract off a half, then that's a number from negative 0.5 to 0.5. And same for y. And then we add that velocity to the position of the cell. And then down in the main loop, instead of just updating the player, we're going to update all sprites. So let's say for s in disp.sprites, s.update, and 4, and I think that should do it. This works because every sprite in our display at this point has an update method, so we don't have to check for it or anything. Hey, look at that, cells are wiggling around. Pretty nice. Now let's see if we can add some collision detection, make them react to touching the player. So first I'm going to make a method to detect if a cell is touching the player. So that's cell.touchingPlayer. Oops. I think I clicked outside the window. First we're going to calculate the distance between the cell center and the player center. So that's the square root of self.x minus player.x squared. Here I'm using the power operator because I don't want to type all this again, that's too much. Plus self.y minus player.y squared. And then under what conditions is this touching? This would be touching if that distance is less than the combined radius of the cells. So the radius of this cell, since the image was defined at 128 pixels wide, which is a radius of 64, 64 times its scale. And same for the player, 64 times player scale. So if our distance is less than that, then we're touching. And now in cell.update we can check for that. Say if self.touchingPlayer, then I hit shift return to give me an if block, then print game over, and we'll just exit the program at that point. If it's not touching the player, no wait, that's not what I mean to say. If it's touching the player, it's either game over or not, depending on the scale. So I got to check the scale here. So if self.scale is greater than the player scale, that means the player is touched by a bigger cell, then it's game over. But otherwise, it means that the player's touched a smaller scale. So what do we want to do here? Well, we want the player to grow a little bit. So player.scale equals player.scale plus, let's say, our scale times 0.1. So some fraction of our own scale, and then we want to remove this cell because it's no longer in the game. So to do that, we'll do disp.sprites.remove. Now remove takes the index of the item that you want to remove from a list. So we just need to get that index by doing disp.sprites, the index of self. There is a module in syslib called listutil, and if you import listutil, then you could just say I'll show you, disp.sprites.remove val self, which is a little bit nicer. But I didn't really want to go into import modules in our very first tutorial, so we'll just do it this way for now. Alright, so let's see what's happening. We defined a function to tell if we're touching the player, we're checking if we're touching the player, we're handling either case. I think it should be good. Let's give it a try. Oh, well, it worked. I touched a bigger cell and the game was over right away. Let's run again. That's something we're going to have to fix. When you start off touching a bigger cell, it's not really fair, is it? We'll come back to that. Okay, here we are. Let's grab some smaller cells. Hey, look at that. We gobbled them up and got bigger. And now I'm getting big enough I really don't have to worry too much. I can just gobble everything up. That is fun. Okay, now we're clearing off the board here, and the game's going to be over pretty fast. We need to have cells spawn periodically. So let's tackle that next. Let's see, where do we create our enemy cells? Here they are. I'm going to refactor this into a separate method. Let's call it new cell. I'm going to hit shift return so that it fills in the end for me. And now I'm just going to grab the guts of this for loop, cut it, paste it, and now we have a function that we can call to create new cells. And I'll go ahead and use that in my for loop, just like that. Let's test to make sure it still works. Yep, still works. Game was over right away, but we'll deal with that later. Okay. So now we want to periodically create a new cell. So I'm going to say the next spawn time, which will initially be 1 second after the program begins. And here we can say if time, which is the current time, is greater than the next spawn time, then we want to do a new cell and set a new spawn time. So next spawn time equals time plus random value from 0 to 1. All right, and now we should see, yep, cells are popping in periodically. Okay. Now, I can foresee that at some point a cell might pop in right on top of the player. That's not fair. And of course, at the beginning of the game, we've already observed several times that a cell can start on top of the player. And that's no good. So let's finally go back and fix that. We have this function to tell if the cell is touching the player, but I want to give a little bit more margin between the player and a cell when it spawns in. So let's add a margin parameter with a default value of 0, and we'll just add that to here. So now it considers it a touch. It'll return true if our distance is less than the total radius plus this margin. And now in our new cell, let's see, we should probably assign the scale first. Oops, hit undo because I fat fingered that. So we have our scale, and now we can do while true, pick a random location, and then if not touching player, then break out a loop. Okay. So this should keep picking random locations until we find one that's not touching the player with, let's say, a 10 pixel margin. Sounds pretty good. Put the mouse in the center of the screen so I'm not moving right away. Hey, there we go. Nothing spawned on us at the beginning. And I think nothing's spawning on us during the game either. So we have a fair game. All right. Now it looks like it's moving more slowly as it gets bigger. It's really not. It's just that proportionate to its size, the amount it moves isn't as much, so it appears slower. All right, let's see. We've pretty much got what we can call a game here. I think the only thing I want to add today is a score. Nothing makes a program feel like a game more than a score, right? So we're going to initialize our score to 0, and let's see, where we adjust the score, that would be where we detect a collision, right here. When the player scale increases and we remove a cell, we are going to also increase the score. Now score is a global variable, and we are inside a function here, the cell update function. So I have to say globals.score, oops. Otherwise I would be referencing a local variable called score, and that wouldn't do us any good at all. When you're reading it, however, because there is no local variable called score, it'll fall back to the global one. It's only on assignment that you ever need to use globals. Unless for some reason you have a local variable of the same name, which is never a good idea. So global score equals score plus, let's see, how many points should you get? How about round of 100 times self.scale? So bigger cells will give you more points. That seems fair. And now we're going to set the text row to 25, which is the row at the very top of the screen, and text.print. I don't actually have to say text.print. I can just say print score. Let's try it. Hey, look at that. I'm accumulating points. This is exciting. 132 points. That's terrible. I'm going to try one more time. All right, so let's see if I can wrap up my talk and play at the same time. We've created a little game here using sprites. Oh, good. It's over. I'll be able to talk better. We created a game using sprites. Every one of these cells is a sprite in the sprite display, which is display 4. To get the image for the sprites, we actually drew it into the graphics display and then just plucked the image right out of that display. Maybe it would be helpful to review the code. So we got a shortcut to our display, we drew our cell, and then here's where we pluck that image out of the graphics display and assign it as the image of our cell. Now we're creating a bunch of subclasses of cell. They all inherit the same image value. That's how that works. Our cells update by wiggling around and checking if they're touching the player. And we have a function that just does a bit of math to tell that. There are other ways to do collision detection that maybe we'll get into in later videos. But when you're dealing with round things, simply checking the distance is an excellent way to do it. And then here's the player cell. The player updates to follow the mouse with a little bit of inertia. We have a new cell function that avoids spawning on top of the player. We use that to create a bunch of cells initially, and then periodically in the main loop we spawn a new cell. And that is pretty much all there is to it. I hope you've enjoyed this video and found it useful. If you have any questions, feel free to post in the comments below, or better yet, hop onto the Discord or onto the Miniscript forums, and I'll be happy to help you out.